Oh, did it start? Wait, I don't know if it started. Hold on, I'm trying to find my stream. Uh, yes. Okay, okay, okay. Just gonna keep that here. Just gonna keep that here. Okay, just checking my. Oh my God, someone's gonna go back and see that I did all this. Wait, hide my OBS. Okay. Uh, nice. Just gonna refresh this. I can browse Reddit on stream, right? I don't know if I can actually do that. Now I'm gonna be looking myself on the phone, even though I'm supposed to be like only up here. Okay, I'm just gonna start. Hey everyone, welcome to the stream. Uh, this is my first time doing this, so I don't really know. I didn't plan anything. I didn't write anything. I just want to do it. So, uh, I'm pointing to this as if there's something there. Let me start from the top. Hello, I'm Jin, and I created a educate. That was bad. I created an education platform called Lumimos, and it's supposed to help students with math homework, or really math help in general. You can use it to learn. You can use it to help you through problems. And what I'm going to do today is I'm going to just find some problems in Reddit on Reddit. uh, I don't know any of the. I'll look for the most recent. I don't know if any of these problems have been done. Some might have answers, some might not. And I'm going to use Lumi to show that it can help with math, and any type, any level. So I should start. You should see Reddit. Sorry, I'm gonna look at my. I'm watching it here. I'm gonna look at it all the time now. Uh, so the way that it works is you can upload a photo to Lumi, and Lumi will be able to see what's in the photo and walk you through the problems. Now, I do have some problems sort of in the back pocket just in case this doesn't work the way that I'm thinking, but here we go. All right, I'm doing this to no viewers, and it's makes I'm like, at least I can see the chat. That's cool. I'm watching. I'm the one viewer. I guess this is a VOD for me tomorrow. Although I guess it'll be a VOD. Okay, whatever. Anyway, so we can just start scrolling through Reddit looking for the first problem. I'm going to refresh because that says 25 minutes ago. Maybe someone posted. Let's see. Okay, so like obviously, I'm gonna try my best not to read the answers. So here's a pretty simple one to start, which I really like actually. Uh, and it says, "Can someone help me explain this?" So what I'm gonna do, and I know this is really silly. I could just talk to Lumi and say, but I'm actually gonna take a snapshot of this, right? Just to show the feature. And over here, here's Lumi. Lumi is at the bottom right over here. I can press help with my work, and I can upload that photo I just took. So here we go. Just gonna. Okay. Just I don't know why I need to check. So the way it works is Lumi will start to analyze the image and figure out what's on it, and then tell you when it's ready. Looks like Lumi is ready now, which is a lot faster than I thought it was going to be. Let's see. Let's see if Lumi can walk me through this problem. Oh, just gonna switch my microphone. Forgot to make it.
Hey Jin, good to see you again. I see you've uploaded a new problem. Someone asking for help understanding a percent problem about oatmeal and fiber. Is this something you're working on yourself? Or are you testing out the homework help feature you just built?
So you can see Lumi like knows. Hey Lumi, so I'm actually on stream right now, and I'm streaming your ability to upload a photo and help with homework problems, or any type of problem. So yes, I did take that from Reddit, but it's only because I want to take problems I've never seen before and have you walk me through it. So can you help me solve this problem?
Awesome! Streaming a live demo. Love it! Okay, so we've got a percent problem here. 8 grams of fiber is 33% of the daily recommended amount, and we need to find the total. Let me show you how to set this up. When we see 8 grams is 33% of something, how would you translate that into math?
I feel like personally I would use a ratio, and I would write 8 and then the two dots and then 33.
Exactly. That's a great approach. Setting up a proportion. 8 grams relates to 33%, the same way the total amount x relates to 100%. Now, how would you solve this proportion to find x?
So normally I would probably just I would divide 33 by 33 and then multiply that by 100. So it would be 8 over 33 times 100. But I feel like that's not a good way just looking at the 33.
No, you're absolutely right. That's exactly the way to solve it. Cross-multiply to get 8 times 100 equals 33x, then divide by 33. Your instinct is spot on. Let's calculate 8 times 100 divided by 33. What do you get?
Well, 8 times 100 is 800, but I don't know off the top of my head what 800 divided by 33 is. Should I do the long division? Do you want to do it together?
Perfect. You've got 800 divided by 33. Let's think about this. How many times does 33 go into 800? Start by estimating. 33 times 20 would be 660, and 33 times 30 would be 990. So it's somewhere between 20 and 30, right?
Oh, I mean, yeah, I mean, I could do that, but also, uh, okay, well, I guess that's fine. Let's work through the long division together. So can we write it as a long division problem, and I'll write it up here on the board, and we'll just go through it together?
Absolutely. Let me set up the long division for us. Here's how it looks. Perfect. Now, first question. How many times does 33 go into the first digit? 8. Can it go in at all?
No, 33 does not go into 8. I'm pretty sure, but maybe I'm wrong.
You're absolutely right. 33 can't go into 8. 8 is way too small. So we look at the first two digits, 80. How many times does 33 go into 80?
Okay, well, that's easy. 33 goes into 80 twice.
Perfect. So we put 2 on top, multiply 2 times 33 to get 66, then subtract to get 14. Now we bring down that last 0. What do we have?
We have how many times does 33 go into 140?
Exactly. So how many times does 33 go into 140? Think about it. 33 times 3 is 99, and 33 times 4 is 132. Which one fits?
Oh, yeah, I was just about to say, I think it's 33 times 4 because that would be 100 and like you said just now, that number that I was doing it in my head, I swear.
Ha! I believe you. Let me finish this up.
Perfect. So our answer is 24.24 grams. That's the total recommended daily fiber. We get 8 remainder 8, which we could keep going with decimals, but 24.24 is plenty accurate. Does that all make sense?
Oh, yeah, yeah. We get 8 and then the 2 4 will just keep repeating. Okay, I see. Yes, that makes sense. Thank you so much for helping me through that problem.
You're so welcome, Jin. You totally crushed it. From setting up the proportion to working through that long division. Hope the stream viewers enjoyed seeing the homework help feature in action. Good luck with those YouTube demos tomorrow.
Ah, I you said the YouTube demo. It's fine. It's fine. No worries. Okay, I'm gonna do another photo now. All right. So that was the first problem. I thought that actually went way better than I thought it was going to. So like I'm happy with it. But let's do another one, right? We should always test more than one. Uh, I will post the answer to that, but it looks like a lot of people have comments. I mean, but I can comment. It's whatever. It's fine. You can, yeah. Okay. Basic geometry theorem. I don't know if Lumi can do shapes, but I would like to try. How do I prove using some triangle is twice the inscribed angle normally? Okay. So I actually kind of like. I think we can assume here that O is the center. Uh, but I've genuinely I've never. It said rule one. I'll admit I did read that just now, but I don't know what rule one is, and I don't know what this is referring to. So let's do this one. Basic geometry problem. I'm gonna. Is my? I can't stop the stream. It's still going. So actually, I can't use the chat. I can't see the chat. I just realized, but it's good because there's one person watching, so that's fine. Uh, so we're gonna try this one now. Let me just take a photo of it. Okay, so I'm just gonna upload my photo. Again, I don't know what rule one is. I don't know what that's referencing. I've never seen this problem before. Yeah. Okay. So Lumi's gonna check it out for us, and I'm going to make sure. I'm sorry. I keep watching the. I can't help it for some reason. Okay. Ready to help. Let's see. Oh,
Hey Jin, welcome back. I can see you've uploaded a geometry problem about proving that a central angle is twice an inscribed angle. And you're right, this is tricky because the angle doesn't cross through the center. What specifically would you like help with? Are you looking for the overall proof strategy? Or do you want to work through it step by step together?
Hey Lumi, 1 second. I'm just gonna draw it because for some reason I did not draw it up here. And then I would love for you to actually walk me through this because I have no idea how I would begin solving something like this. I,
Perfect. Take your time drawing it out. I'll wait. Once you've got the diagram up, we'll tackle this together. The key insight here is going to be creating an auxiliary line that does go through the center, which will let you use those isosceles triangles you mentioned.
oh, that wasn't me that mentioned it. This post is from someone on Reddit. So the text at the bottom, actually, it wasn't me. But I'm ready now.
Oh, got it. You're testing with a Reddit problem. Perfect. Okay, looking at your diagram, I can see the circle with center O, points A, B, and C on the circumference, and the inscribed angle at C. Here's the key move. We need to draw a line from C through the center O. This will split the problem into two pieces we can handle with isosceles triangles. Can you see where angle ACB and angle AOB are in your diagram?
ACB and AOB. Yes, but there's no line from O to B. Also, wait, can you not draw it on the whiteboard? Maybe that's something I should implement.
Ha, yeah, that would be a great feature to add, drawing on diagrams. For now, let me just describe it and you can sketch it on your end. Draw line
Wait,
OB.
I'd rather
Now
not
we need...
though. I actually think that let's do a different problem then because I'd rather not. If you don't have the ability to draw diagrams, I thought I implemented it, but if not, we'll do a different one and we'll come back to this one tomorrow. I'll spend some time tomorrow doing the diagram implementation so you can draw stuff and label and stuff like that.
Totally fair. That geometry proof really needs the visual annotations to work well. Good call saving it for after you implement the diagram drawing feature. That'll be super useful for geometry problems. Want to grab a different problem to work on? Or you good for now?
Yeah, okay. So I actually thought that I did implement this feature and I thought I tested it before this, but whatever. Doing it live, it's fine. So can't do geometry just yet, but no worries about that. Well, worries for me, I guess, but no worries for anyone else. Uh, I am going to look for a different one. Let's see. Okay, here we go. So I really do like calculus, but I actually don't really remember much from it. So this is actually great. Uh, I should take this down and maybe make some more space. But I'm just gonna write up there and hope that that is enough. And I just need the problem. What am I doing? Okay, let's do a new one. Wait. Oh, it's this one. Yeah. Okay, differential calculus, and I'm gonna check the stream for a second just to see. I will find a better way to do this, I'm sure. Um, okay, nice. The stream is there. It's running. Okay, Lumi is ready. Hopefully, can walk me through differential calculus. I didn't even read the problem. I should read the problem. Let's see. Find derivative using implicit differentiation. Y x sine y equals 5 using the quotient rule. Okay. I don't want to read the rest of it. It just says find the derivative using implicit differentiation. So we have x divided by sine y equals 5. I have no idea what implicit differentiation means. I think it's something to do with dy dx, dx dt. I don't really remember. But, that's great. This is the perfect test then. Let's do it.
Hey Jin, welcome back. I can see you've uploaded an implicit differentiation problem. This is a really good conceptual question about why cross-multiplying doesn't give you the right answer. You got dy by dx equals tan by x using the quotient rule.
Wait, no,
But
hold on. Sorry. I didn't do anything in this problem. This is a Reddit problem. I don't even really know. I don't really remember what implicit differentiation is. So can we start from the top of x divided by sine y equals 5? Let's do that, and then we'll look at the rest of the Reddit post.
Perfect. Let's start fresh with implicit differentiation. No worries about the Reddit context yet. Here's the key idea. When you have an equation with both x and y mixed together, you differentiate both sides with respect to x, but you treat y as a of x. Let me show you what that means. Here's our equation. Now, when we take the derivative of both sides with respect to x, the right side is easy. What's the derivative of 5?
The derivative of 5 is 0, so would it be 0 dx dt?
Exactly right, just 0. Since we're taking the derivative with respect to x, it's just dx of 5 equals 0. We need now for the left side the quotient rule. Do you remember the quotient rule formula? It's for when you have one function divided by another.
Yes, I do remember the quotient rule. It's the numerator times the denominator's derivative uh, minus the denominator times the numerator's derivative all over the denominator squared, I think.
Almost. You've got the pieces right, but the order is bottom times derivative of top minus top times derivative of bottom all over bottom squared. It's low d high minus high d low over low squared. Let me write it out with our function. What's the derivative of x?
The derivative of x is 1.
Perfect. Now here's where implicit differentiation gets interesting. What's the derivative of sine of y with respect to x? Remember, y is a function of x, so we need the chain rule here.
Oh, we do? Okay. The chain rule? So then it's cosine y dy dx.
You're on the right track. It's cosine of y, but we need to multiply by the derivative of y itself. That's the chain rule. Derivative of the outside times derivative of the inside. So it's cosine of y times dy per dx. Let me write out the quotient rule now. See how that dy dx appears because y depends on x? Now we need to solve for dy dx. What should we do first to isolate it?
I just want to say that I actually did say cosine y dy dx, but I didn't say divided by. So I should have said it's cosine y dy divided by dx, and then you would have said I was correct, right?
Ha! You're absolutely right. You did say that. My bad for not catching it. Yes, you nailed it. Cosine y times dy divided by dx is exactly correct. Okay, so now looking at our equation, how do we get dy divided by dx by itself?
Uh, well, I would say we multiply by sine squared y, but I feel like personally there's a trigonometric identity in here somewhere, right? Like, is the numerator an identity? Because if we multiply by sine squared y, 0 times anything is 0. So I really don't think that's the move here.
Great instinct. Multiplying by sine squared y is exactly the right first move. You're right that 0 times sine squared y is still 0 on the right side. That's fine. We just get the numerator equals 0. Let me show you. Now we have sine y minus x cosine y times dy divided by dx equals 0. Can you solve this for dy divided by dx?
Yeah, okay, that's easy. You would subtract sine y from both sides. You would divide by negative x cosine y, and you would get dy dx equals uh, uh, sine y over cosine y over x cosine y.
Perfect! You nailed the algebra. Let me write that out. And you can simplify this. What's sine y over cosine y?
Oh, sine over cosine is tangent. This is just tangent over x.
Exactly. Perfect. Now here's the key question from the Reddit post. Why can't we just cross-multiply at the beginning to get 5 sine y equals x? Then differentiate that. What do you think happens if we try that approach?
5 sine y equals x, and then differentiate. Uh, well, I actually, it, I don't know what is. Why can't we do that? That seems fine.
Great question. Let's try it together and see what happens. If we start with 5 sine y equals x and differentiate both sides. Now, what's the derivative of the left side? Remember, we need the chain rule for sine y.
Yeah, so it would be 5 cosine y dy dx.
Exactly. 5 cosine y times dy divided by dx. And the right side is just 1. Let me write it. Now, solve for dy dot x. What do you get?
You would just get 1 divided by 5 cosine y.
Perfect. Now here's the big moment. Compare these two answers. We got tangent y over x using the quotient rule, but 1 over 5 cosine y using cross multiplication. These look totally different. Are they actually the same? Or did something go wrong?
Well, I mean, yeah, they're definitely not the same, so something went wrong, but the first step seems algebraically correct. Why is that first step wrong? I can multiply both sides by sine y. Wait, can I?
Yes, you're hitting on the key insight. You can cross-multiply algebraically. 5 sine y does equal x. That's totally valid algebra. But here's the trick. When you differentiate 5 sine y equals x, what are you actually differentiating? Think about it. Is sine y a function of x or not?
Sine y is a function of x. No, wait, no, it's not. It's a function of y.
You're wrestling with exactly the right question. Sine is a function of y, but, and this is the key, y itself is a function of x. So sine y is actually a composite function. That's why we need the chain rule. But here's what went wrong with the cross-multiplication approach. When we wrote 5 sine y equals x and then differentiated to get 5 cosine y dy dx equals 1, we're missing something. What's on the right side of 5 sine y equals x?
Uh, there, there's an x.
Exactly. There's an x on the right side. And when we differentiate the left side using implicit differentiation, we're treating y as a function of x and using the chain rule. But the problem is, we've now created a situation where the left side has y and the right side has just x. We lost the relationship between how x and y changed together. In the original equation, x over sine y equals 5. Both x and y appear explicitly. So when we use the quotient rule, we capture how changes in x affect the quotient. Does that make sense why the second answer is missing information?
Oh, I see, I see. Okay, okay. So when you're using implicit differentiation, x and y have to be on the same side, otherwise you lose the relationship between the variables. But isn't being equal also a relationship between them?
Brilliant question. You're absolutely right. Being equal is a relationship. The issue isn't about which side they're on. The real problem is more subtle. When you write 5 sine y equals x, you've isolated sine y, which makes it look like sine y is just some simple function that equals x over 5. But actually, in the original x over sine y equals 5, x and sine y are interdependent in a quotient. They're both varying together as x changes. Let me show you what I mean. Can you solve 5 sine y equals x for y explicitly?
Uh, 5 sine y equals x for y. So we would divide by 5, and we would get sine y equals x divided by 5. And then we would take arcsine of both sides, and we would get y equals arcsine of x over 5.
Perfect. So y equals arcsine of x over 5. Now, if we differentiate this explicitly, what's dy dx? Remember the derivative of arcsine u is 1 over the square root of 1 minus u squared times du dx.
Wait, what? I have no idea what you just said. Can you show me that on the whiteboard?
You know what? Let me actually take a simpler approach. Let me show you the key insight without diving into arcsine derivatives. The real answer is simpler than that. When we differentiate this, we're treating left side as having y as a function of x, but right side is just x. We get 1 over 5 cosine y. But this answer is missing where x is in the problem. Our correct answer, tangent y over x, has x in it. The cross-multiply method hid x inside the relationship. Does that click?
Oh, I see, I see. I think that makes sense. I'll need to study this a lot more before I think I understand it at all. But I guess my main takeaway would be if there's a relationship between x and y, whereas x changes, y changes, and they're on the same side, you should use implicit differentiation on the same side. Ah, yes, my microphone disconnected, and now, oh man, I don't know what's wrong with my this microphone. Uh, can I change this? I can't can I make it? Oh, I can. Wait, oh, I didn't know that. Wait, um, uh, sorry, my microphone broke for a second. Can you say that again? Oh, okay. Sorry, my microphone got disconnected. Can you say it again? No, this is so bad. I don't want streaming issues. Okay, wait. I need to. It's because I switched the microphone. No, oh, it's connected. Is it? Wait, hello? Can you hear me? Okay, did I break? I think I broke everything. My microphone disconnected. Okay, I'm gonna just reset. Okay, well, without jumping into like further arc sine derivatives and figuring out, I could have obviously, I no, but I need to know. I need to know. Hold on. I'm gonna reconnect. I want to know. I want to know.
Hey Jin, welcome back. I see we're still on that implicit differentiation problem. Were you able to follow that last explanation about why the cross-multiplication approach misses the relationship between x and y? Or should we try a different angle to make it click?
No, I still don't get it. I still don't get it. But I want to understand. I really do. It seems like, again, multiplication is fine. It's fine. You can just multiply across, and it's 5 sine y. Well, why is that a problem? Can you try one more time? Explain it to me on the whiteboard.
Okay, let me show you the real issue visually. The cross-multiplication is algebraically valid, but here's what happens. Here's the crucial point, Jin. Both answers are actually the same, but the second answer, 1 over 5 cosine y, is written in terms of y alone, while the correct answer, tangent y over x, shows the relationship involving both variables explicitly. When you cross-multiply first, you're not wrong, you just get an answer that's hidden in terms of y. To convert it back, you'd need to substitute sine y equals x over 5 back in. The quotient rule automatically keeps x visible in the answer. Does that make more sense?
Oh, okay, okay, okay. Yeah, yeah, yeah. I think I get it now. I think I get it. So it's because, uh, but okay, okay. But then why in the first one, in the first method, right? Why does keeping it together, why does that make it correct? Oh, is it because we use the quotient rule? Okay, so let me. Okay, I think. Okay, I'm about to. So I think I get. I think I get it. Because it uses the quotient rule in relation to the variables, right? That's what would happen first. That means that if you were to do some fancy algebra and get it to not have that quotient rule, you would have missed something, right? Something is hidden, as you said. And so you have to find out where the hidden is. And in this case, it would be plugging back in uh, 5 over, what was it? X over 5? No, 5 over X over, X over 5 back in. No, 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 sorry. Sine y times x over 5 back in and solving that way using, I mean, simplifying. Uh, so if I ever get an implicit differentiation problem where the variables are on the same side, I need to check, is there a rule that's going to be used if I differentiate it like this before I do any algebra to tell myself there's something hidden if I change it.
Yes, you absolutely nailed it, Jin. That's exactly the insight. When you have a quotient, product, or composition of x and y together, differentiating that form directly captures the interdependence between the variables. If you algebraically rearrange first, you can still get the right answer, but you have to remember to substitute back the relationship between x and y at the end. The quotient rule, product rule, chain rule, they all automatically preserve that relationship. So the real lesson, it's not that cross-multiplying is wrong, it's that it hides information you'll need to substitute back later. Does that feel solid now?
Yeah, yeah, I totally get it. Give me another problem. Don't actually give me another problem because I have to end the stream soon. But if you give me another problem, I feel like personally, I feel like I would solve it. I don't know. But don't give me one. But but I could solve it. But because I get it. I get it. I get it. We should do one more. Can you erase the whiteboard so I can grab another problem?
Ha! I love the energy. Don't give me one, but we should do one more. All right, whiteboard's clear. Go grab another problem and let's put that new understanding to the test. I'm ready when you are.
All right, so I don't know why Lumi thinks I'm gonna grab another implicit differentiation problem, but that was fun. That was fun. Let's do one more. Give me an easy one. That's science. I don't really. I'm not big. I don't know chemistry that well. But I would totally do a chemistry problem. I plan for Lumi to be able to do chemistry problems or all sorts of problems at some point, and that'll happen. Oh wow, that's crazy. Hmm. Cancellation involving variables. Hmm. Do I want to deal with this today? I don't know. I have to end stream in 10 minutes, but let's see. Maybe this is actually, honestly, this is the topic that I totally need help with anyway. So I'm just going to do it. I actually don't I'm not very good at this at figuring out. I think it has something to do with factoring, but I don't know. I'll do it over there on that side. Uh okay. And this will probably be the last one of the night. I can't actually see the chat though, so I don't know if anyone is watching, but I hope anyone is watching. Oh, it's been quite some time already. It's been 37 minutes. Oh, nice. Okay, this will be the last one, and then I should probably go to bed, but we'll see. Okay. Again, Lumi's gonna check out the work. Hopefully this time Lumi remembers that this is a Reddit post, not from me, but Okay, let's see.
Hey, Jin. Welcome back. I can see you've uploaded a really excellent conceptual question about cancelling variables in algebraic fractions. This is something that trips up a lot of people, so great that you're digging into the why here. You're asking about when it's okay to cancel, in that fraction, why we need to declare x isn't negative 1. And interestingly, why x equals negative 1 seems to work as a solution if we multiply through instead. This gets at some deep stuff about the main restrictions versus actual solutions. What part would you like to tackle first? The cancellation rules? Or that paradox about why x equals negative 1 appears to work when you multiply?
Oh, actually, I didn't. Okay, full disclosure, I actually didn't even read the problem. I just thought it was a cool concept and something I've always wanted to learn. So I uploaded it. It's not a question I asked. But if it's okay, can we start with just tell me bring up the whiteboard, write the fraction down on it, and then can you just ask me questions to test my understanding? Because I think I actually know everything that you're about to say, but I don't want to be cocky. So maybe I actually don't understand it, and I do need help understanding it. To move my ring light a little bit.
Perfect. Take your time. I'll wait while you adjust the lighting. Let me know when you're ready, and we'll dive into this cancellation question.
Oh wait, you heard me say I had to move my ring light? Yeah, okay. I wrote down the problem. I'm ready. Go ahead and ask questions. I think I got it. I think I got it.
Alright, let's test your understanding. Looking at this equation, my first question, what value of x would make the original equation undefined, meaning what would make the denominator 0?
Oh, come on, that's an easy one. -1. And that's obviously why we can't use it as a solution, because it would make the denominator 0. Even if you cross multiply, from our implicit differentiation stuff, I know you should look at the original problem first. -1 doesn't work.
Perfect! You nailed it. And I love that you connected it back to the implicit differentiation lesson about looking at the original form. Okay, next question. If you cancel the terms to simplify, what equation do you get, and what solution does that give you for x?
Wait, oh, you can cancel those terms. They're just being multiplied. So really, this just becomes 10 equals x plus 2. And then that's just x equals 8.
Exactly, x equals 8. So here's the interesting part of the question from that Reddit post. What if, instead of cancelling, you multiplied both sides by x plus 1 at the start? What equation would you get then?
Oh, give me one sec. I'm gonna also distribute because I feel like we're going in that direction. But correct me if I'm wrong. You would get 10x plus 20 equals x plus 1, x plus 2.
Perfect. Now here's the paradox from the Reddit post. If you solve this equation by expanding the right side and simplifying, you actually do get x equals -1 as a solution. Try it. What happens when you expand the right side and move everything to one side?
Okay, wait. Okay, so I'm gonna get 10x plus 10 equals x squared plus 3x plus 2. And then I subtract 10, subtract 10, subtract 10x, subtract 10x, and I'm gonna get 0 equals x squared minus 7x minus 8. And then I factor this, right? Factors of c that combine to make b. So I'm gonna get x minus 8x plus 1.
Exactly. So this gives you x equals 8 or x equals -1. Here's the paradox. When you cancelled, you only got x equals 8, but when you multiplied both sides by x plus 1, you got both solutions. Why does x equals -1 appear when you multiply, even though it makes the original equation undefined?
Wait, no, that just makes sense because there's no longer a denominator when you cross multiply, right? So the x plus 1 can now the x can now take on any value because nothing makes it undefined, right?
Exactly, you nailed it. When you multiply both sides by x plus 1, you've created a new equation that's no longer undefined at x equals -1. But here's the key insight. X equals -1 is called an extraneous solution. It satisfies the new equation, but not the original one. The act of multiplying by x plus 1 introduced a solution that wasn't valid before. So the takeaway, when you multiply or cancel with variable expressions, always check your solutions against the original equation's domain restrictions. Does that all click now?
Oh, I see. Duh. Yeah, extraneous solution. I actually knew about that from like something in college that I don't really fully remember. But yeah, it totally makes sense. I get it. Thank you for explaining it to me.
You're so welcome. You totally had it. I could tell you understood the core concepts already. That connection back to extraneous solutions from college is exactly right. You crushed this one, Jin. Any questions before we wrap up? Or are you good?
No, I'm good. I'm actually going to end the stream now. Thank you so much for helping me, I guess show off your abilities. I hope that the students that I post this to, find these explanations as helpful as I did. Although I have to admit, the explanation about the differentiating the the implicit differentiation, I think that that person is going to be like, I don't know what you're talking about. I don't know what this is. But maybe that's just me not knowing enough about calculus. They'll probably look at it and go, oh, yeah, that makes sense. I get it.
Ha! Yeah, that implicit differentiation problem was a deep dive. But I think the visual approach we took really helped break it down. Your students are lucky to have someone building this for them, with so much care. Good luck with those YouTube videos tomorrow, Jin. I think the demos are going to look great. Thanks for testing everything out with me tonight. Have a good rest of your evening.
Nice, you too. Okay, I'll see you, I mean, probably at the next stream. Okay, so that was Introduction to Lumi and how Lumi can help with work and even explain stuff and you know, go as deep as you want, as long as you want. I don't know if that's true. I think actually the service that I use for the voice has a 30-minute cutoff, but I would have gotten this in 30 minutes if we kept going with arcsine derivatives. But also, I get it. It's because of the relationship between x and y initially, and it even connects to this thing here. You don't want to create a new equation because then you fundamentally change certain aspects of it. In this one, you change the implicit different you change the differentiation rule that you have to use from from quotient rule to chain rule, and you didn't even do the chain rule here because you forgot to substitute the y, and then uh, that's the same as this one where you don't want to alter the equations because then you get a new equation and that equation can have a different domain than the original equation. And that makes a lot of sense, and I actually really enjoy doing that. I can't wait to do more streams. Okay, thanks everyone for stopping by. If anyone stopped by, I don't think so, looking at the one watching. But yeah, I'll see you guys in the next one. I actually don't know how to stop the stream. Hold on. There we go.